All right, there we go. So now let's look at the rest of the renewables. We started with wind. That's number one. All right, right at the top of the list. It's the fastest growing segment of the alternative energy. Hydroelectric has been around for a long time. Building dams, using gravity, goes back to the early 1900s. Blocking the rivers, making electricity, small streams as well as large ones, all right? Running that water, do we convert it to steam? No, but we run through gravity, we run that water to turn a generator with what inside? You got it, all right? Very inexpensive, our cheapest source of power. Every state in the nation has these, have been around for a long time. The issues, of course, you already know. It's blocking sand. Those reservoirs that are held back behind every dam, those reservoirs will have a finite life. Small reservoirs will fill in. That sand is blocked from going to the beaches. Meanwhile, the fishes want to travel up the streams to get to the shallowest waters to get away from their predators so they can have their babies. And they can't do that, and they're throwing themselves. I've seen this go to every dam, and you're during the migration times, and you'll see fishes throwing themselves, wailing at the walls, trying to get across. All right? And with that, you also build giant reservoirs. Here is the Three Gorges hydroelectric dam in China. Look at the power. Every one of these feeding a generator. Every one of these, a separate generator room, opening it up. China, huge population, has got a great demand for energy. And of course, what they did was bury many very historic villages, controversial as it was. And so what are you going to do? China is out there, nuclear power, solar, wind, coal. They've got lots of coal. And this is the cocktail of energy. All these different blends in different countries have different resources. Some countries have no coal, oil, or gas. South Africa. So they turn to other ways. Okay. Other ways. Solar. All right. Probably number two after wind. A fast-growing segment. And there's different kinds. 3 different kinds of ways we use this. I won't talk about the lowest energy. That's where you put solar panels on your roof that just hold water and make it warm. And you can have hot water in your homes and your hot tubs, okay? That's a hot water. That's not making electricity. That's number one, not making electricity. Then, number two, also with panels, they kind of look similar, but these use silicon or cadmium, which are semiconductors, and the photons hit that metal, silicon from quartz, hit that metal causing electrons to flow. Remember that quartz is pyro and piezoelectric, okay? Electricity flows with heat and with pressure and with just sunlight, and the electricity flows, okay? So these are photovoltaic cells. And number 3, I will talk about it first, is extreme energy, where you concentrate the light. How many of you have ever taken a magnifying glass out into the sunlight and made a hot spot? And went around and popped stuff. Ooh, I was really good at getting ants and doodlebugs. Or pill bugs. What did you do? Set leaves on fire. Yeah, I did a lot of leaves on fire, all right? How much fun that was. How many of you have done this? Yeah, we love fire. How many of you killed things? Gender indifferent. Oh, man, woman. And so here is concentrated. So here we have several thousand mirrors all around concentrating that light. Water goes up the tower and gets flashed to steam. So steam, once again, steam, all right? And that steam then rushes out and through a generator with magnets making electricity. So that's concentrated. Here we're using thousands of mirrors. You can also do it one mirror at a time, just like you with one magnifying glass at a time. There they are, highly polished, new technology. Here's a startup company. Is this you? Here's a startup company in the garage in their backyard making these things for everybody to use. All right? Concentrate that light, put it in one spot. The industry is interested. The investments are there. Are you ready? Look at them all. And the president of this company is going to burn something.
Hello there, I'm your host, Dan Rojas, and I have a real quick video.
He's just a kid.
Next to a large 56-inch parabolic dish. And I actually have a bunch of them. We're going to be doing
I want to do this.
some tests in the future with some steam videos to see if we can chain them together and get a realistically good quality of steam. This dish is probably 2 times as powerful.
So they're making these and selling it. All right.
56-inch.
It's just part of the product.
The focal length on it is really good. It's near perfect parabola. So it's a shorter focal length. I'm going to show you really quick.
The focal length is where it comes together. It has to be really close. It's right there, not far away. It's burning, it's burning. There's a reflection.
Fire already. Really strong. Now,
good job. So, you know, all kinds of ideas. Are you ready for this? All kinds of ideas. Are you on board? Photovoltaic cells are also developing and changing. For years, we used silicon. All right? Here are panels being put out. We need sunny areas, not a cloud. Well, a few clouds in the sky. All right? The cost has generally been fairly high. We're trying to get it less than 9 cents per kilowatt hour. All right? And a new company called First Solar out of Tempe, Arizona, has said they have done it. And they built one using, instead of silicon, cadmium and tellurium. And this is true. Their stock before mid-December 2010 was only around $13. And then it jumped to over 151. And last year I had a student who actually raised his hand and says, I own some of that stock. I said, what did you buy it at? $12. Are you rich now? Yeah. So you heard it right here in Earth Science 105. Okay? So silicon is used in your computer chips, made from quartz. Silicon, very abundant mineral, simply SiO2. We convert it, we drive off the oxygen, and we make pure silicon. And it's quite stable, it's harmless, it's inert, all right? And electricity flows when you hit it with sunlight. Cadmium telluride is even stronger, although cadmium, unlike silicon, is toxic. So that's the side issue, but more powerful. Can we do it? Where is Massachusetts in this? Fully involved. Look at all the solar panels going up each year, smaller in number, but you know, by now, the cumulative, the total number is really taking off. So this is a big industry, even close to home near us. All right?
Sunlight is made up of tiny packets of energy.
Well, there it is.
Photons. Every minute, enough of this energy reaches the Earth to meet the world's energy demand for a whole year.
Looks like snow, but those are supposed to be
panels
photons.
consist of many solar cells. These are made of materials like silicon, one of the most common elements on Earth. The individual cell is designed with a positive and a negative layer to create an electric field, just like in a battery. As photons are absorbed in the cell, their energy causes electrons to become free. The electrons move toward the bottom of the cell and exit through the connecting
There goes
wire.
electric current.
This flow of
Light bulb.
electrons is what we call electricity. By combining solar cells and photovoltaic panels, we can produce just the right amount of electricity.
So these
to
panels
perform
can be
specific
made for any
jobs,
size,
no matter
and any
how
job.
large or
All
small.
right? We use them out on our highways to help warning lights come on when they're needed. So they're powered by the sun. No batteries, no electric wires. They have a little bitty job. And here's a whole house running the power of that house. Think about the industry. Let's cover the roofs of Boston University, and many schools are doing this. Let's go green. Geothermal. You like hot springs? I know you like a hot tub. All right? Nothing like it. Well, hot springs that we have talked about, geysers that we have talked about, that's a great resource. Where are the areas of the world that it's hot in the ground? Now, the average geothermal gradient is how hot it gets as you go down. It's like 20 degrees centigrade per kilometer. So it gets hotter. Why does it go hotter when we go down? Jacqueline? Why does it go hotter? Closer to the center of the earth. Good. Why does the earth get warmer on the inside? Pressure. It does get more pressure. What else? Radioactive. Radioactivity. Great. Yeah. Radioactivity. So our earth is radioactive, and that's still out there. So the earth is hot, But in some areas, it's not 20, it's 75 or 120. All right, so those areas that have natural heat, we can really use. You don't have to go down very far, and you send cold water down. It gets heated to steam, is what we really want. And then where do you run that steam? Alex?
Through a turbine.
Yeah, through a turbine or a generator, okay? With magnets on the inside. You got it, you got it. So we dig down into the cold areas. We simply run water through, all right, the areas of the world that are hot. Be the western U.S. for us. Look at the rest of the world. So find out. Hey, look at Hawaii. And the United States is #1. How about that? You didn't know. We're #1. All right? Followed by the Philippines, Indonesia, Mexico. There we go. Iceland, way down. But that's total in megawatts. Turn around and do this per capita. What does per capita mean? Per individual. All right? And Iceland would probably be at the #1, or Costa Rica or El Salvador. All right, not as many people. So there it is. That's the thing. Western United States, here in Reno, Nevada, capturing the steam, making electricity. Look at the power coming out. Geothermal well, just like a geyser. So we have made a geyser. All right, and in that, controlled and making energy. So a lot of the geothermal wells are in the western United States. The red areas where it's really hot. A good part of Nevada, some in California, a whole lot in California, Oregon, whatnot. In fact, that last plot looks different. It looks like California is leading in this one over Nevada, who is #2, and so on. North Dakota, hurry up. Alaska, come on. Even in Iceland. So here is a well being dug. It's cold out there, so they've got a dome over it where they're drilling down. That's a borehole house. It's kind of cold. And making the steam, capturing the steam right there. It's so wild. Let's go. It's hard to separate hot springs, geysers, and geothermal plants. So here is a real live geothermal plant in Iceland with people clothed or unclothed. I have no idea, but it's fun to guess. All right? What would you do? Yeah. And so the U.S. geothermal forecast, I lost my years here, but it goes from the year 2000 through 2010, about where we are now. And this is projected. So this, in geothermal's here. All right, it's big. And what a great source of clean energy. Okay, beautiful. And the very first one in the nation, located at what's called the geysers, north of Sacramento. Very first geothermal plant, 50 years old now, been there, and now look at us. We're on our way. The fossil fuel era, the doors of the fossil fuel era are starting to close. Okay? And you're there. Here's one that we can't have geothermal in Boston or Massachusetts, but we do have this. We got tides. What creates the tides? He's sleeping. Woo-hoo, got you. Oh, okay, all right. Yeah, oh look, all right. Looks like you're sleeping. All right, so the tides. The moon creates the tides once a day or twice a day? Yeah, usually twice a day, although some places get 4. Some places just get 1. Depends on the geography and the latitude. But as the ocean goes in and comes back out, this is really being studied. Do you want a PhD? Go study how to do this. And find out where you can do this. The first thing you got to do is go map where are the high tides. Who has really fast moving tides versus slow. So we got to map it. Here's what the industry looks like. This is a cartoon, but mounted to the seafloor are big fans that are moving as the water goes by them. All right, so it's like a windmill underwater. It's a water mill. It's a water mill, and it cranks a turbine. Yeah, or a generator. Same thing. All right, there you go. Look out. That's the same kind of deal. So it's a water mill, and it goes forward and then back. So you got to make sure that when you build it, because it's going to go one way half the day, the other way, it doesn't suck electricity back, right? You always be creating the electricity. There we go. Where is it? All over the world. We can find the areas. We want it really red. All right, we want it really red. Look at Massachusetts. So we're in a hot spot for tides. But where should we go? Look at Australia. Whoa, big tides. Look at Japan, the Philippines. Look at the Aleutians and Alaska. There's lots of areas that have really rapid tides. How many of you have been caught out in tides? You ever been out in a channel? Have you? What happened?
spot in Richford.
Okay, it'll get you, won't it? That's right. Scary movement of water. So you want to be practical with this. And here we are closer to home, mapped out. We want things that are yellow and orange, and look at all that. This area up by Cape Cod, huge tides right in there. Of course, don't get out there and get caught in it. It'll pull you out to sea. But as it goes, so this is where you would invest. This is where you would go and build your own energy company. Off we go. Biomass has many meanings. It's a broad topic. If some of you are shopping for topics, you can divide this up. Biomass could mean burning wood. It could a fireplace. It could mean burning garbage and making electricity. The state of Connecticut burns its garbage. Hardly anything goes to a landfill. They burn it. All right, they burn it. And what they burn, they use that heat to do what? Heat water to make steam, and the steam goes to a turbine generator, and off you go. Okay, so that's one way, but it's many more. But we can take, all these cuttings and simply burn it, send it to a boiler, make the steam, go send it to a generator. That works fine. But it means other things. We can grow crops, and from the crops, like corn, we can make alcohol and fuel. Just don't drink it. Yes, Emily?
Is it mostly water vapor that powers generators?
Yeah, steam vapor. All right, so there's lots of ways. We can make alcohol from grapes. That's wine. Don't drink it. Use it as a fuel from corn. Of course, I've talked about garbage. We even can go to landfills, garbage dumps, and collect the methane gas that comes out. Because when you biologically decompose in the absence of oxygen, you make methane. It's part of the decomposition. So capture it. So biomass means lots of different things. All right? It's a very broad topic. And it does have some issues. You're burning a fuel. Waste materials are not available all year. You got to get out there and collect it. But it's great. I have a compost. I love having a compost. And that compost gets everything out of our kitchen, from coffee grounds to banana peels and apple cores, along with clippings from the yard. And if I stick my hands into it, it's warm. Steam comes out. And in there, thriving and having sex and reproducing are worms. Worms. It's the top of the food chain because they're eating the bacteria and reproducing. They're reproducing. All in my compost. And in time, the material breaks down. I could use the heat to make steam. All right, I'm sending it to my garden, but that's biomass. All right, don't send it to a landfill. So I can't wait when you no longer live in dorms and apartments, but have a home with a yard where you can have a compost and let it be warm and full of worms doing their thing. Biomass. All right, we have 3 R's. We have 3 R's, and we talk a lot about recycling, but what are the other 2? And they're the better. Reuse and reduce. Reuse. I'm reducing what goes to a landfill because I'm sending it out to a compost where I'll reuse it, all right, not to a landfill. There we go. All right, learn to recycle. Hey, wait, do that again. I love that.
With Chambers and
Elizabeth, I love her.
Your source for living an eco-friendly lifestyle. Algae is the fastest growing plant life and an organism that converts sunlight into oil. Scientists theorize that algal biofuel can produce a whopping 30 times more energy per acre than any other biofuel option.
Okay.
The U.S. Department of Energy has estimated that if algal biofuel replaced all conventional fuel in the country, it would require 60,000 square miles of land to harvest the algae, which is roughly 1/7 of the area that is used to harvest corn in the U.S. every year.
I believe everything she
And
said.
a diverse group of byproducts and feedstocks for producing plastics can be created in algal biofuel operations, making the production more cost-effective. But before we start celebrating the great biofuel solution we've been looking for,
Look at
there
the
are
green
key
stuff.
problems. The biomass for producing a significant amount of algal biofuel just doesn't exist yet.
But
The
they're
algae
working on
have
it.
to be grown from scratch, and harvesting it.
So
is
companies are
very
coming
expensive
together,
at this
investments are
point in
happening.
time. The potential of algal biofuel is staggering, but the problem is that as of now, it's all just potential. It might be years before the technology catches up to
We'll get here.
producing algal biofuel on a large scale possible. But when that time does come, we might be finally ready to celebrate a more efficient, renewable, and environmentally friendly energy source. For more information on this exciting and developing technology, check out algalbiomass.org.
Okay.
Elizabeth Chambers, check back here for more
Bye, Elizabeth.
and tips right here on livinggreenchannel.com.
Living green. So there you have it, and there it is. All right, so ExxonMobil, they're out there, no longer an oil company. They have combined with La Jolla biotech firms outside San Diego. We need a lot of sunlight, and there it is. And look at it, they're growing algae, producing electricity. So it's really happening, Gabby. Oh, cool. $50 million of investment has come from the Defense Department to fuel algae research. So it's really great. And that's what it looks like. Oh, yucky, yuck. It's green because it's live. It's green because it's through photosynthesis. All right? And it's all part of it. So lots of biofuel companies are starting up with presidents and vice presidents and founding members and boards of directors and architects all getting together. But here's another thing. Also biomass. We can take corn or grapes or just about any grain. Wheat. What's vodka made from? Wheat and rye, different kinds. Okay? Corn whiskey. All right? Or you can use it as a fuel. So in Brazil, you pull up, you've got gasoline pump here and an alcohol pump here. Which one would you have? Of course, what they found is that the taxi drivers were drinking it. Pretty good stuff. You ever drunk Everclear? Have you ever heard of it? Oh my God, you have? In my cabinet, in my kitchen, I have 190 proof potato alcohol made in Poland. Want some? I got stories. And now hydrogen, the future of energy. Hydrogen, the #1 element. There it is on the periodic table. #1, you take two hydrogens together and you fuse them. And that is a hydrogen bomb, all right? Fusion. You take hydrogen and react it with oxygen. That's not fusion, but it's an exothermic reaction making, what would you guess? H2 plus O equals water. And it turns out water is very stable, you know, at surface conditions. Hydrogen and oxygen, when they get together, their relationship, they come together and it's explosive. All right? Wow. They explode in making H2O, exothermic reaction. I was once in high school, believe it or not, 1,000,000 years ago, and we had a tank of oxygen and a glass tank of hydrogen. And I got elected to go up and open the valves to let the two come together. And the explosion that happened was an accident. It shattered the lab. I got sent to the principal's office. I never understood what I did wrong. I just opened up all the way. Open them up all the way? No, get out of the room, evacuate. Okay, it blew up. So hydrogen is used in different ways, all right? One is the way I'm describing, combining hydrogen going across a membrane to combine with oxygen. Here comes the oxygen, here comes the hydrogen. They go out as water and you get an explosive, control it. And you've got a very strong power source, okay? No generator here. We're making electricity. We're making a battery. We're making a battery from hydrogen. The flow of electrons, all right, are all there. We can power that. So here's a BMW 12-cylinder engine, 260 horsepower. Will go to 0 to 62 miles per hour in 9.5 seconds. Can you imagine that? Holy cow, sit back and let's rock. So these are developing fuel cells, and now for fusion. A lot of research has been done on this now and in the past, and it's a very active area. It's the fuel. Why am I showing you the sun? What's the fuel of stars? Hydrogen. Undergoing fusion Two hydrogens fuse them together, and you make the number 2 element in the periodic table. Number 2, way over there. Helium, all right? And then you take a third hydrogen, you fuse it to the helium, and you make lithium. And you start marching through the periodic table, 5, 6, 7, 8, marching through. You make the entire periodic table from fusion, okay? But it all starts with hydrogen, and that's the fuel of the sun. The chemistry of the world is made in stars. So I told you one time, long ago, that you were born from the stars. And you came to Earth as a shooting star, right? And partly as a comet. And then you came out of Earth, I told you, through a volcano. All right? And then you started life at the bottom of the ocean. That was you. That's your history. And so the entire world, the entire chemistry of you and everything else comes from fusion, making up the entire periodic table. Okay? So there it goes. Take 2 hydrogens. Here we're using H2 and H3. They're different isotopes of hydrogen. Fuse them together. We make helium, and the energy release is 4 times greater than uranium fission. I already told you what 1 gram of uranium can do, right? It was huge. Now multiply it by 4, and you've got fusion. What fusion can do, it's big. 2 hydrogens, we make helium. We're studying this all over the world. Okay? And we can make the other elements too. So you're going from lighter elements to heavier cures of the sun. Also the hydrogen bombs. Maybe some of you do your PowerPoint on hydrogen and fusion. Can we do this? The trouble with it all is that it requires 1,000,000 degrees centigrade. The sun is hot. It requires 1,000,000 degrees. So we're looking for ways to do it with magnets and lasers, electric currents, trying to do it cold. Can we do it cold fusion? And research lab after research lab throughout the world has been studying this. The success is moving forward, but it hasn't hit what everybody's looking for in terms of achievement. So it's there. So beyond fossil fuels, are we ready to leave them behind? They've contributed to the greenhouse gases that are building up, and it's not going to go away unless we do something about that. All right? We got a lot of coal, we know. Are we going to keep burning that? Or are we ready to go beyond fossil fuels? And certainly nuclear is here, but what's next? Where are you going to put your future? Wind? Solar? The biofuels? Biomass? Well, now you know what some of these things mean and where you're going to go. All right? And then ultimately, fusion. From fusion to fuel cells, all of that part is using hydrogen. Windmills of time. As we look at this, we are in a changing era of human history. Once again, and it's all about the Earth's environment, and it's all about the Earth's energy. Okay? Have a good rest of your day.